So now we are gonna study about the hash tables. Alright, we'll understand what are hash tables and we'll be implementing those in our Typescript. So what are hash table actually? A hash table, also known as hash map, is a data structure that implements an associative array abstract data type. Alright, is a data structure that implements an associative array abstract data type. A structure that can map keys to values, keys and its values. So it uses a hash function to compute an index into an array of buckets or slots from which the desired value can be found. You got it? So it will also have nodes, and let me kind of visualize it for you. Okay, so hash table and hashtable.ts. So here what will happen is that I key and the value. Okay, key and the value. So you will get the key, alright, and it will return you the value of it like this. Okay, so to further understand, let us implement this in Typescript. I'll create a class hash node on top of which we will be building our hash table like this. What is coming here? All type parameters are unused. Okay. Key of type K, value of type V, and next hash node of type K V or null, means there can be no next value. Constructor here, key and the value. This dot key equals to key, and this dot value equals to value, and this dot next equals to null, like this. So our implementation of hash node is done. This is the base. On top of this we will be building the hash table. Now let's create a class hash table, and here also KV. So private table, it will be an array hash node KV. It will be an array of hash nodes. So private size, private capacity, number, and private load factor. You will understand what this is. Okay, so these are the fields that we are gonna have. Now let's create a constructor. Here we will be taking initial capacity. Initial capacity will be of type number and the default value will be 16, and load factor type number will be 0.75. You got it? Now this dot capacity equals to initial capacity, and this dot load factor equals to load factor. Now size initially will always be 0, and this dot table equals new array. This dot capacity of the array will be the one which we have provided, dot fill with null values. This is how this will be instantiated. Alright. Now let's implement our methods. So first, our important method called as hash function. So private hash key k returns a number, and const string key equals to typecasting it to the string. And now let hash equals to 0. Right, or you will get confused, so hash var. Okay, now for let I equals to 0, I is less than string key dot length I plus plus, hash var equals to, like, we will be doing a bitwise operation like this, and string key dot car code at I. This is how we are hashing. Okay, that is how we will hash. So if you don't know about bit manipulation, it will take too much time to teach you right here, so you can check any tutorials on YouTube. What are the bitwise operations? Again, hash var equals to hash var and hash var, like this. This will convert it into a 32-bit integer. Okay? This will convert the hash var into 32-bit integer. Now return match.absolute value hash var and modulus this dot capacity. This is our hash function. This is how we are going to hash our key. Now we are going to implement put method to insert or update a key value pair. Put key of type K, value of type B, this returns nothing. So what I'm gonna do is if this dot size is greater than or equal to this dot capacity multiplied by this dot load factor, then we are going to resize it. So for that, we are gonna create our resize function. So I will be creating my resize function. Sorry. resize function like this, and void now const old table equals to this dot table, this dot capacity into equals to 2 means double. Now this dot table equals to new array, this dot capacity dot fill now, and this dot size equals to 0. Now for bucket of old table, const, now current equals to bucket means that we are going through each and every value of the table that was previously there, each and every element present inside that table, that will be basically called a bucket. Now, as long as you have the current value, what you're going to do is that this dot put current dot key, current dot value, okay, current equals to current dot next. This will be our resize function, okay. Now here what I'm going to do is that I will resize like this. Now let's continue with our put function. So what we are going to do is I'll get the index const index equals to hash key. From the hash function I will be getting the index, and new node equals to new hash node, key y. Now if the table does not have that bucket actually at this index, what you are going to do is this dot table index equals to new node. Basically you will insert a node at that index, size will be incremented, and you will return the function. Means you have inserted it. Now what if the key already exists? So let current equals to this dot table index, and let previous equals to null. Now while you still have the current value, what you're going to do is that if current dot key triple equals to key that is provided, means you got to update this right here, current dot value equals to value, and return. Simple. That's what you have to do. Otherwise previous equals to current, current equals to current dot next. Alright, now the next of the previous will be set to new node, okay. We are now adding a new node to the chain actually. If the value exists we update, otherwise we are adding a new node, and size will be incremented as always. So this is what your put function will look like. Now I'm going to create a get function so that you can get the key. Get key of type k and returns value or null. If the value exists, then it will return, otherwise nothing. Again, so I'm gonna get this, copy and paste it here, and this also here. And now, while we still have current, what I'm gonna do, I'm copying this function as well. So here, I will return the current dot value. Like this, otherwise keep moving, and return null. I mean, if nothing is found, then we will return null. Okay. Now let's implement our remove function. So again, I'm gonna take a few things. I will take this. So remove also will take the key parameter, and if it got removed, it will return true, otherwise false. So I'll paste it here, and pref will set to null. We'll need pref because next value of pref will be the next value of the current. So while you still have the current, what you're gonna do is that here, if you have a previous value, then pref dot next equals to current dot next. That's what we usually do. But if you do not have the previous value, then this dot table index equals to current dot next. You add it to the bucket of the table. That's it. And here size will be reduced for sure, and return 2. Now pref equals to current and current equals to current dot next. Otherwise we will be returning false. Now we will see the contains method. If it contains the key, return this dot get key not equals to null. Alright, so if it is not equals to null, then it will return true, otherwise false. Get all the keys. Alright, return an array of keys. So I will create an empty array, and for const bucket of table, let current equals to bucket. So one bucket, here you understand, bucket, and it is the current value dot next dot next dot next, and then there will be another column inside a table. There also current dot next dot next dot next. That is how the bucket of the table is working. Okay, that is how the bucket of the table is working. This is very important for you to understand. So while we still have the current value, keys dot push current dot next, current dot key, and current equals to current.next. So it will keep moving and return the keys. Alright, so this is how we implement the keys method. Now we will be implementing the values method. Okay, I will copy this and I will paste this values here, values and current dot value, and here v, and our job is done. This is how you will be returning all the values. Okay, now some miscellaneous methods like get size. Okay, return this dot size. Okay, and is empty. How I'm gonna check if it is empty? Can you guess it? Just simply checking the size is 0. Okay, I also have to return and clear. I'm gonna clear this dot table equals to new array capacity dot fill the array with all the null values. Okay, and size set to 0. That's it. That's the complete implementation of a hash table, guys. Okay, that is how you implement the hash table, and now we are gonna use it. Okay, const hash table equals to new hash table string number and hash table dot put like age will be 25. Don't guess my age. Yeah, I'm 25. Alright, and marks 0. Okay, let me give myself like 30 marks. Okay, hash table dot put number of bugs created. Okay, ridiculous. Now console.log hashtable.get age, console.log hashtable.keys, console.log hashtable.values, and console.log hashtable.remove number of bugs created, console.log hashtable.keys. Running. Now look at that, the age, the keys, the values, and I removed it and then it came like this. So our hash table is working like a charm. Alright, this is how you implement a hash table in TypeScript. And now what we are going to do is that we will be learning heap. Okay, the heap data structure in TypeScript.